Okay, I think we are live. Amazing. Okay then. Let me check on different device. All right. Should we do this? So I had a break, like a really long break. So I was thinking to go through it again. I got some time today. Maybe we should learn something together. Yes, let's do this. Hello. Nothing. Just I'm just live and going through the Rust docs, so nothing much. All right, let's go through this thing. Fundamentals of asynchronous programming, async await features and streams. Hello. So let's do this. So coming from the web dev background, you must be aware of these things. Async await, right? So let's see how it goes. They offer two techniques of working on more than one operation at a time: parallelism and concurrency. This is Rust. Rust, it is, bro. Say you are exporting a video you have created. Yes, Rust. Am I? How's the stream going, guys? How is the stream going? Am I audible? Okay, that is good. That is good. The video export will use as much as CPU and GPU. Okay, so the operation that could take anywhere from minutes to hours. The video export will use as much as CPU and GPU. If you only had one CPU core and your operating system didn't pause that export until if it executes the export synchronously, you couldn't do anything else on your computer. Well, fortunately, your computer. Mhm. That is good. That is good. That's fascinating. Maybe I could give it a try. So yeah. It take some time for is quite large. Hmm. Yes. Yes, I am on GitHub. Uh, all right. So why 943? We should be able to write a program so that starting one download won't lock up the UI and the user should be able to start multiple downloads at the same time. Many operators that interact with the network are blocking, though that is, they block the program's process until the data is processing. We can avoid blocking our main thread by spawning a dedicated thread to download each file. However, the overhead of these threads would eventually become a problem. Yes, it would be preferable if the call didn't block in the first place. So it would also be better if we can write in the same direct style we are using in blocking code similar to this. Yes, it is. Fetch data from dot await. So I did these, async await when I wrote my any HTTP server. So I'll be like I use probably Actix Web framework for that, and it provide these things. You will okay. How to use Rust's async and await syntax. How to use the async model to solve some of the same challenges we looked at in chapter 16, and how multi-threading and async provides complementary solutions. Mhm. A concurrent workflow switching between task A and B. All right. We have treated parallelism mostly interchangeable so far. Now we need to distinguish between them more precisely. So the difference will show up as we start working. Consider the different ways a team could split up. You would assign each member one task or use the mix of the two approaches when an individual works on a so this is going to say maybe you have two different projects checked out on your computer, and when you get bored or stuck on one, you switch to other. You're just one person, so you can't make progress on both the tasks at the switching between them. Switching between task A. So these are the tasks, and probably it says that as a single individual you have multiple projects. You can't work on multiple projects, but you can switch between them. So this diagram is kind of like that. So when the team splits up the group of tasks by having each member, so task A and task B. So maybe these are the two different teams working on multiple different projects. So that is parallelism. Each person on the team can make progress at the exact same time. Mhm. In both of these workflows, you might have to coordinate between different tasks. Maybe actually got one person on team to finish their task first. Couldn't done in parallel, but some of it was actually serial. It would only happens in series, so one task after the other. All right. Hmm. Independently until task A3 is blocked on the result of B3. Okay. Ah. The same basic dynamics come into play with software and hmm, when working with async and Rust. Probably I can see some chats here like this. So we are always dealing with concurrency depending on the hardware, the operating system, and the async runtime. We are using more on async runtimes shortly. That concurrency may also use failures on the hood. Now let's dive into how async programming in Rust actually works. The key element of async programming are futures and Rust async and await keywords. Alright. A future is a value that may not be ready now but will become ready at some point in the future. Alright, so it says the key element of asynchronous programming in Rust are basically these three things: a futures and a Rust async and await keyword. So here it tells about what a future is. A future, is a value that may not be ready now but will be ready at some point of in time in future. The same concept is sometimes under the other names such as task or promise. So must be aware of promise if you are from a JavaScript background. Rust provide a future trait as a building block so that different async operations can implement it with it different data structures but with common interface. So basically futures are types that implement the future trait. Alright, each future holds its own information about the progress that has been made and what ready means. You can apply the async keyword to block uh, to blocks and functions to display okay. It can be interrupted and resumed. Within an async block or await keyword to await a future. Uh, I hope you guys are like getting this thing. So if you have worked with promises or if you're aware of async await, then this would be fairly understandable, right? You can use the await keyword to await a future. Hmm. That is wait for it to become ready. All right, any point where you await a future within an async block or a function is a potential spot for the async block or function to pause and resume. The process of checking the future to see if its value is available is called pooling. Okay. Some other languages C Sharp and JavaScript also use async and await. Okay. Keywords for async. If you're familiar with those languages, you may notice some significant differences in how Rust does things, including how it handles the syntax. All right, so all these three paragraphs, it basically saying that the element of asynchronous programming in Rust are basically few things. Rust's async and await keywords that we are going to use whenever we implement a future and Rust future. So basically Rust future is something that implements a future trait. So future is a trait in Rust. If anything that implements a future trait is a future. And why it's a future? Because it tells about a particular piece of code that it may be available in some in some point of time in future. All right. Okay. Did I miss anything? Yeah, one thing is missing. It says the so the process of checking a future to see if its value is available yet, is it available yet or not, is called pooling. All right, when writing async Rust, we use async and await keyword most of the time. Rust compiles them into equivalent code using the future trait, much as it compile for loops into equivalent code using the iterate trait. Because Rust provide a future trait, though you can also implement it for your own data types when you need to. Many other functions. So let's write our first async program, a little web scraper. So have you guys written a kind of scraper? I wrote it, but it's in JavaScript, like Node.js. Will pass in two URLs from the command line, fetch both of them concurrently, and return the result of whichever one finishes first. This example will have a fair bit of new syntax. That's all right. Hmm. Trades function primarily from the future and Tokyo creates. Da, 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 da. Anyone? All right. Hello async, and I need to add trpl create. What is a trpl create? TRPL also renames the reps the original page to keep you focused on the detail. Okay. Here it is. There are other great runtimes. We use the Tokyo create under the hood for TRPL because it's well tested. Now we can use various pieces provided by TRPL thread first. Okay, let's see how it is. Uh, Page title. So if I want to fetch a page title of any specific URL, I'll pass in the URL on this function. I have added a async keyword in front of that function. It means this function will run asynchronously, right? So it's similar, somehow a little bit similar to any async function we write. Let's take example of a JavaScript function. So if I want to make await JavaScript function, that function has to be async, right? So in order to use await on a function, it has to be async. So similar to this, we have written async keywords over here on the definition, right? It takes a URL, returns an option of a string because it could be a null value also. I'll use trpl create. I'll say get URL await and a response text await. I'll parse it a response text. I'll have the first select title map. I'll map it and get the inner HTML, possibly the title value. Defining an async function to get that. This is fairly simple. I hope you guys understand this thing. We have created an async function. It takes a URL, returns an option of string. These are the functions provided by trpl create. I'll just use get URL. I will await it. As soon as I get the response, I'll get the inner HTML of it. This paragraph pretty much explains what I did. So let's skip this thing. Uh, Chaining the await. So this is called chaining. I get the URL, I await on it. As soon as it gets resolved, I'll use this thing again, dot text dot await. So it's called chaining. Da, da, da. Okay, that is fine. So it basically updates it, this code piece over here, by using chaining. Right, determining a single page's title. We'll just get the title of a single page. Uh, this code doesn't compile. The only place we can use the wait keyword in async because this won't mark us. The special function main function has async. That's okay. We cannot define async on the main function. However, we can do that by using some, macros. on top of it, but it's a different thing. Maybe we'll see it in next maybe chapter or something. Okay, racing two URL against each other. Mm-hmm. So we have used this thing. So we'll be defining two URLs on our env. So this thing captures those thing on a vector. So we'll have two URLs over here, and we are going to raise them by checking whichever runs or executes first. So run is an associated function provided in trpl crate. All right, this entire block is async. Here it says trpl raise title feature one not await. Okay, okay, yeah. This is our page title function. We are passing the URL in it. All right, returning a tuple of a string slice and an option of string. Okay, so this is our kind of raise function that we discuss. So if you are like have it on your side, maybe you guys can run this out. Hello Himanshu, what's the agenda of this live stream? Nothing. I mean, I've been not actively live from past couple of weeks, so I thought let's give it a cold start. So yeah, that is it. How about you, buddy? How you doing? Yeah. So basically, I thought that what should I like do on live? So I just have been going through. Sorry. Chapter 17 of Rust book. Okay. Yes. Good to hear that. I'm doing company work with my coding agent. It is doing for me. Nice. That is good. So, what kind of tool are you using? I'm using Kiro. Okay, okay. Uh, it is from AWS. It's nice. You should give it a try. Yeah, sure. We'll do that. I'll give it a try. Mm, all right. Okay. Yeah. Okay. So let's creating a new task. So it's now the next chapter is applying concurrency with async. The first operation we tackle creating a thread where spawn was counting up to the two separate threads. Let's do the same using async. Should supply a spawn task function that looks very similar to thread spawn and a sleep. We can use the implement the counting example as shown in this thing. So I spawned a task, run it to 10 counts, and after that I am again running it to 5 counts, and it's going to sleep after 500 milliseconds. Alright, this closes over here, and all these things, right? So as a starting point, we'll set up our main function. This so the top level functions can be async. Then we write two loops within that block, which waits for a half second. So I get this. So there is a question, interview questions that that follows this pattern using loop and promises, something like that in JavaScript, not here. You should be aware of that. Give me a minute, guys. Hello. Do do do. I always get this. Cool. Mm, that's way too big, but I'm sure I'm not even aware of any of these. Hmm. All right, guys. That will be all for today. I'll see you in the next one, maybe with some uh, project that we can scratch. So, bye bye. Thank you, all the people, for being here. Bye.